Okay, picking up where I left off with this one, I'm going to look for this one in my LCD. Looks like it's going to be an x and a 2, and then I say, oh, I got x squared, so I'll make this an x squared instead of a 2, instead of just x. So my LCD is going to be 2x squared. So I'm going to multiply everybody by 2x squared. So 2x squared times 1 over x equals 2x squared times 3 over 2x squared. I'm going to change this, make that a negative 1. So plus 2x squared over 1 times negative 1 over 2. I just hate to lose that negative sign. So now I'm going to cancel. X goes into x squared x times, so this is plain old 2x equals the 2x squareds cancel. I have 3 plus I have a 2 cancels here, and then this is really negative 1x squared. So this is a quadratic, so I need to make it equal to 0. I'm going to add the 1x squared to both sides and subtract the 3 so that my x squared is positive. So I have x squared plus 2x minus 3 equals 0. So x plus 3, x minus 1, I believe is how I factor it. So x equals negative 3 or 1. And so neither of those would make my denominator 0, so I can keep both of them. All right, so now let's do a few word problems. This first word problem we did in class. This word problem down here, I don't know if we did it yesterday or not, so I'm going to do it again. We've got a berry farmer. He's got 2 adjacent fields, and he's got a lake on one side, so we don't have to worry about that, and he's got 240 yards of fencing. So if I think about this, if I draw it so that it's not really in the picture, this side I don't worry about. That's the water side. But I want to split it here. So I have a width, I have a width, I have a width, and I have 1 length. So the length plus 3 widths is going to be 240. So solve for the easiest letter, and the easiest letter is L. So L equals 240 minus 3W. So now what you're going to do, you want to, largest total area, you want to maximize the area. So area is equal to length times width. So I'm going to plug this mess in for L. So that's 240 minus 3W. Then it has to be times W because that's still sitting over there. Now I'm going to distribute, and I get 240W minus 3W squared. You see how that's a quadratic? That opens down, okay? Which is on the x-axis, which is on the horizontal axis. Well, that's the width is on the horizontal axis. The A is on the vertical axis, so I'm looking I have a maximum area. So I'm looking for my vertex. All of these go back to the vertex if you haven't figured that out yet. So my vertex, W, which is really like X, equals negative B over 2A. So it's negative 240 over 2 times negative 3. So negative 240 divided by negative 6, I think is just 40, right? 240 divided by 6. 240 divided by 6 is just 40. So my width is 40. So my width is 40 yards. Okay, now I have to find the length because I need to find the largest area. So the length, I just have to go back and plug it in. I could either plug W in for here to find the area. Let's just do that. Area equals 240 times 40 minus 3 times 40 squared, whatever that is. If they ask me for the dimensions, then I have to make sure I find L. But they didn't ask me for dimensions. They just said, what's the largest area? So I'm typing it into my calculator as I talk to you, and my calculator says 4,800. So the maximum area is 4,800 square yards is my maximum area. Okay? This one is similar to the first one. You're looking for when does it reach its maximum height. Okay, so this is an upside down parabola because of that -8. Again, this time what's on my horizontal axis? T for time. And what's on my vertical axis? H for height. So you're trying to find when will it reach its maximum height. So you're looking for the time. So remember, that's your vertex again. So time, which is acting like x, equals -b over 2a. So -80 divided by 2 times -8. I think that's 5, right? 5 seconds. Okay, so now I'm going to plug that back in. So at 5 seconds, it reaches its maximum height. What is the maximum height? You're going to do h of 5. So -8 times 5 squared plus 80 times 5 plus 25 is whatever that is. -8 times 25 plus 80 times 5 plus 25 makes 225. So the rocket is a height of 225 meters, because that was the unit. So that's the maximum height. Okay, last one real quick. In business, profit is determined by the difference between revenue and cost. Revenue is the money they take in. Cost is the money they had to pay out. So I have revenue is this. So my profit is the revenue, which is my 50x minus 0.5x squared, minus my cost. Here's my cost, 10x plus 3. I just put parentheses in them so I don't forget something. So this is really 50x minus 0.5x squared minus 10x minus 3, or negative 0.5x squared plus 40x minus 3. So the question is, find the maximum profit. So we have to find the maximum profit, that's my y value, and the number of units that must be sold, that must be x. Notice again, this is an upside down parabola, or a parabola that opens down. X is the number of units, and the y is my profit. So I'm looking for my vertex again. Surprise, surprise. So my maximum profit happens when x equals -b over 2a. So -40 over 2 times -0.5 gives me just 40. So I have 40 units. And then my maximum profit is going to be P of 40, which is -0.5 times 40 squared plus 40 times 40 minus 3. So -0.5 times 40 squared plus 40 squared again, because that's 40 times 40 minus 3 gives me 797. So 797, I'm assuming that that's dollars because it's a profit thing. So the maximum profit is $797 when 40 units are sold. Okay, there you go. I think that's it, right? Yep, that's it. All right, good luck. Make sure you study for tomorrow. See you tomorrow.